Friends, welcome back to a new video. In this session, we are talking about the integration of trigonometric function by successive reduction. In this topic, in this video, we want to find the integration of cos raised to nx dx. In the previous video, we learned that how to find the integral of sin raised to nx dx. So this is same as this cos raised to an integral of cos raised to nx dx, which is same as the procedure as followed from integral of sin raised to nx dx. So let's start how to find the integral of cos raised to nx dx. So let's start the session. So before starting the session, don't forget to subscribe our channel due to more videos are coming soon. So let's find how to find the integral of cos raised to nx dx. So first we know that what is integral of cos x dx, which is equal to sin x. So this is come from the integral which is opposite to the derivatives. So we can easily find what is the integral of cos x dx, which is equal to sin x, from d by dx of sin x, which is equal to cos x. Then alternative the sign from this side to this side, the same sign. So there is no change in the sign. So integral of cos x, which is equal to sin x. So let's find what is integral of cos raised to nx dx. So first put in is equal to integral of cos raised to nx dx. Then change the term as integral of cos raised to n minus 1x into cos x dx. In the next step, we want to find or put the rule that the integration by parts. So we know what is the rule for the integration by parts, which is said in the previous video. So let's put these things in the integration by parts, that's followed by this equation. Then we get as in, which is equal to integral of first, we put that this is the first function, that is first function which is equal to cos raised to n minus 1x, and the second function which is equal to cos x. Then we can write it as here that cos raised to n minus 1x is the first function into integral of second function, that is integral of cos x dx, that minus integral of d by dx of first function cos raised to n minus 1x. Then this one as same, that is integral of cos x dx, then put the dx. So we get by the integration by parts, we get this typical formula. Then in, which is equal to though so here we say that in the previous video, in, which means that I means integration and n means the nth power of the, that is this nth power of the cos function. So in, which is equal to cos raised to n minus 1, there is no change. Then the second one, integral of cos x dx. We know what is integral of cos x dx, which is equal to what? Integral of cos x dx, which is equal to sin x. So note here that here integral of cos x dx, which is equal to sin x plus c, there is an integral constant is existing, but there is no need to write these constant here, due to in this final result we will be put a plus c here. So there is no need to write here a plus c. So let's write the cos x dx. That's integral of cos x dx, which is equal to what? Sin x, positive sin x. Then minus integral of d by dx of cos raised to n minus x, which is equal to what? By using the formula d by dx of x raised to n, which is equal to n into x raised to n minus 1. By using this formula, we get the value for d by dx of cos raised to n minus x, which mean that n minus 1 into cos raised to n minus 1 minus 1, which is equal to n minus 2x. Then finally we want to find the derivative of cos x due to the reason of chain rule. Chain rule is here existing, so we want to find the derivative of the separate function cos x here, which means that d by dx of cos x, which is equal to minus sin x. Then integral of cos x dx, which is equal to the same one, that is sin x again, then whole dx. In the next step, in, which is equal to cos raised to n minus 1x into sin x, there is no change this term after onward. Then minus integral of n minus 1, here put minus and minus, which is equal to plus sign here, and n minus 1 into the outward of the integral. Then n minus 1 into put integral cos raised to n minus 2x sin x into sin x, which is equal to what? Sin square x dx. In the next step we get in which is equal to cos raised to n minus 1 x sin x plus n minus 1 integral of cos raised to n minus 2 x. Here sin square x, by using the equation sin square x plus cos square x, which is equal to what? 1. Then here we can easily find the value of sin square x, which imply that 1 minus cos square x here. Then put the value for the sin square x, then we get it as 1 minus cos square x. Put the dx. In the next step in which is equal to cos raised to n minus 1 x into sin x plus n minus 1 integral of cos raised to n minus 2 into the opening the bracket, then we get integral of cos raised to n minus 2 x dx minus integral of cos raised to n minus 2 x into cos square x, which means that cutting the minus 2 and plus 2 here power, then we get cos raised to nx dx, that is cos raised to nx dx. After the next step in which is equal to n minus 1 x sin x plus n minus 1 integral of cos raised to n minus x dx, we can write it as in minus 2, that is the integral of n minus 2th power of the cos function, minus write this as in, that is the integral of the nth power of the cos function. Then put the bracket here. Then after we want to multiply n minus 1 with these by opening the bracket, then in which is equal to cos raised to n minus 1 x sin x plus n minus 1 into in minus 2 minus n minus 1 into in. Then take the value minus n minus 1 in into the left hand side from the right hand side, then we get in plus n minus 1 into in which is equal to cos raised to n minus 1 x sin x plus n minus 1 in minus 2, then open the bracket, then in plus n in minus in which is equal to cos raised to n minus 1 x sin x plus n minus 1 in minus 2. Then cut the in and in here, then we get in which is equal to cos raised to n minus 1 x sin x plus n minus 1 into, put the in minus 2 as the previous one, that is the value integral of cos raised to n minus 2 x dx here. Then finally we can find the in. From the previous part we want to take the n value into the right hand side from the left hand side, then we get the equation as divide the whole equation by n, that is in which is equal to cos raised to n minus 1 x sin x divided by n plus n minus 1 divided by n into integral of cos raised to n minus 2 x dx. This is the solution for integral of cos raised to nx dx, that is the in, that is this thing in, which means that what? Integral of cos raised to nx dx. So in this video we derived the expression for integral of cos raised to nx dx. This is the expression for integral of cos raised to nx dx, that is cos raised to n minus 1 x into sin x divided by n plus n minus 1 divided by n integral of cos raised to n minus 2x dx. So in this next session we can talk about the how to use this formula from different types of question where exist. For an example, how to find integral of cos 4x dx, etc. So we can see in the next session. So if you like this video, so don't forget to subscribe our channel and please like this video. And if you have any doubts, so please comment in the comment box, and the previous video which link is provided on the description box. So let's wind up this video, then see you soon in the next video. Thank you.